Welcome to Easy Math TV. This is our first in a series on exponential patterns or relationships between two variables, x and y. We're not even going to use equations today. We're just going to talk about the pattern itself, patterns in data, okay? So I thought it would be interesting if we compare three different data sets here, because we've already talked about other types of patterns or relationships between x and y, and we can see those two in this video as well. But then we're also going to see the new one, which is exponential pattern. So the three patterns that we're going to see in this video are linear, quadratic, and exponential. So in front of you, I want you to take a look at the three patterns, how we're going to recognize them. So how are we going, what are we looking for? That's what you see over here. What is the description of that mathematically? And then what is our conclusion? So we're going to be putting our x's and our y's into our spreadsheet in the columns, okay? And then there's some calculations that we're going to make with them. So we're going to see, first of all, that delta x is constant. So that is required. We need the delta x's to be constant in order to establish the pattern from our data. So start with that. Start with calculating your delta x and make sure that that is constant. The first possibility then is that delta y is constant, and that means that y is linear over x. It means that we have a common difference pattern, So you can copy this into your notes. When delta y is constant, there is a common difference pattern, and that means that y is linear over x. The second possibility that you see in this table here, if delta y is not constant, but delta y is constant. So we've seen that in a previous video, delta y. There's no actual description of that pattern, but we can say then that our conclusion is that y is quadratic over x. So if you were to graph the curve, it would be a quadratic curve, and you could actually use Excel to find the equation of that quadratic function as well. Then the third possibility that we're going to discover today is that delta y is not constant, and also delta y is not constant. You're going to see that. But there's a third thing that we can do. We can take our delta y's and divide them by y each time. If that is constant, then it's what we call a common ratio pattern. We have a common ratio pattern, and that means that y is exponential over x. It is an exponential growth or decay situation. Exponential patterns happen all the time in finance, so that's very important. So that's why we talk about that. We talk about that function right here at this point of our study. Okay, so let me move that aside. We're gonna first set up our spreadsheet with our x's in column B, because I want to put our delta x's in column A. So column A is going to be delta x, column B is going to be x, column C is our data set number 1. So data number 1. These are our y values that correspond with those x values there. So that's data set number 1 in column C. Then I want you to skip a column. Column D is going to be for our delta y's. In column E, we're going to put our data set number 2. So these are our y values that came with the second data set. And we'll see in a moment, but we're going to need to calculate our delta y's and then our delta y's for that one. And then our third data set is over here in column H. And there are 3 things we're going to need to calculate, because you always check delta y first, and then your delta y, check those first. And if you don't get a constant with those, then your third option is that the ratio delta y divided by y might be a constant. If you don't get any of them to be a constant, then you have there still could be a relationship between x's and y's, but it's not one of the three that we just mentioned. Okay, so let's get right into our calculating here. Let's do column A first. So in row 3, because we can't start with row 2 because there's nothing to subtract. So we start in row 3 and we type equals and B3 minus B2. So we're subtracting the current the x value that's in that row minus the x value that's right above it. And just click on the anchor and fill down. So you will see that that is constant. So that is the that is required in order to proceed with our calculations. So let's look at our first data values of y. So these are our first y values. And we're going to calculate delta y. So in column D, type equals, and that's going to be C3 minus C2. C3 minus C2, fill down. And we see that that is constant. It's the same value repeated over and over again. That's what constant means. So that tells us that y is linear. Our data set number 1 is a linear pattern. Data set number 2, when we go over here and calculate our delta y's, we get equals E3 minus E2. Click on the anchor and fill down, and we see that that is not constant. Therefore, it is not linear. So, we've disqualified from the linear, but maybe there's a quadratic pattern. So I have to move down again to the next row down and type equals, and I have to type F4 minus F3 because I need to be able to subtract what's in the current row minus what's in the row above it. And now we're subtracting our delta y's. So this is change in delta y. And fill down. And yay, that is constant. So when our delta y's are constant, then we know that y is quadratic over x. Okay? But you have to start with delta y there. Delta y has to be not constant, and then delta y is constant, and that tells us that we have a quadratic pattern. Let's look at data set number 3. These are our y values that you see here. 3, 6, 12, 24, 48, 96. I'm going to first subtract. Let's first calculate our delta y's. H3 minus H2. And fill down. And we see definitely that is not constant. So not linear. Let's look at our delta y's. So now we have to go down and down to the next row and do I4 minus I3. Scroll down, and there's only 4 of those. And again, that is not constant. Therefore, it is not quadratic. So our last possibility then is that it might be exponential. If it's exponential, when we divide delta y divided by y each time, we're going to get a constant. And it doesn't have to be a whole number, by the way. None of these had to be the delta y's or the delta x's. Constant just means constant. It can be a fraction. It can be a decimal. So in cell K3, type equals, and we're going to divide I3, the number in I3, by H3. So that's our delta Y divided by Y. 0.5, scroll down, and that is constant. 0.5 is constant. So it's not linear, not quadratic. You have to eliminate those as possibilities first. But then when we did our delta y divided by y, we got a constant. Therefore, for our third data set, y is exponential. Y is an exponential pattern over x. So we'll see in our next video what that actually means in terms of an equation, and how we think of it in terms of like growth and decay, and how that pattern works. Okay, so we're going to learn about that in our next video. Like, subscribe, comment down below, share these videos with people if you think they might find them useful. And there you have finding patterns in numbers from data.